Welcome back. So I'm going to define the word Lagrangian. Let's say that we are trying to find the extreme values of f subject to the constraint g is equal to 0. The Lagrangian for this optimization problem is the function L of 4 variables x, y, z, and lambda that's equal to f of xyz minus lambda times g of xyz. So we are thinking of L as a function of x, y, z, and lambda. Let's see what is the gradient of L. So L here is called the Lagrangian of this optimization problem. The partial of L with respect to x would be the partial of f with respect to x minus lambda times partial of g with respect to x. So Lx is fx minus lambda gx. Similarly, Ly is fy minus lambda times gy. Lz is fz minus lambda times gz. And the partial of L with respect to lambda, well, since when we take the derivative with respect to lambda, f of xyz would be a constant, so this would be with respect to lambda, the derivative of this term would be 0, and with respect to lambda we get negative g of xyz. So the partial of L with respect to lambda is negative g of xyz. So that's the gradient of L, and if f has a extremum at some point p satisfying this constraint equation, then at the point p the gradient of the Lagrangian must be 0. Where I mean by 0, I mean the 0 vector. So in other words, at a point where f may have a extremum, the gradient of the Lagrangian is 0, and if I write this equation in expanded form, that would mean Lx is 0, Ly is 0, Lz is 0, and L lambda is 0. But Lx is fx minus lambda gx, Ly is fy minus lambda gy, Lz is fz minus lambda gz, and the L lambda is minus g of xyz. And so we set them to 0. So this is this system of equations here is equivalent to just this one equation here. But the system of equations here, notice that if we can rewrite them as fx is equal to lambda gx, fy is equal to lambda gy, fz is equal to lambda gz. So this system of equations is exactly the same as what we have seen in the previous video. So this system of equations right here, that's exactly the same as this one. In other words, the equation that the gradient of the Lagrangian is 0 is equivalent to this system of equations here. So that means that if I want to solve this optimization problem here, then all I have to do is all I have to do is solve this equation right here. And the good thing about this is it's pretty simple to state that the gradient of L is equal to 0 instead of saying this. Okay, so in the next video we will be doing examples.